Alrighty, I'm going to solve this side by circuit reduction. And then I'll solve this side with Kirchoff's laws. Right, so the first thing we do is reduce these guys. That's 17, right? This is 1 over 17 plus 1 over 19. I'm going to store that in A. Right, so 1 divided by 17 plus 1 divided by 19. I'm going to store that in A. This is 8.972 repeating, and that's A. I've stored it in my calculator under A. And then this is 4, and then that, and then this and this, so that's series. Right, so that's going to be 4 plus A plus 5 plus 6. I'm going to store that in B. So 4 plus alpha A plus 5 plus 6. I'm going to store that in B. 23.972. Right, and then this thing is connected parallel to this guy here. Okay, so that's going to be 1 over 13 plus 1 over B is what I called that guy, right? And I'll store that in C. So 1 divided by 13 plus 1 divided by alpha B. Storage C. 8.429. And now it's a solvable circuit. We got a 5, an 8.429, and a 3, and that's in series, right? So I can find that current. I'll use the green pen I'll use the brown pen of solving, right? So that current is going to be that I there. I'll call it I1, I guess, right? It goes through here, right? Through this, right? And then this way, right? That's going to be 57 divided by 5 plus C plus 3, right? Where C is 8.429, right? Okay, so 57 divided by 5 plus alpha C plus 3. Store that in D. 3.469, right? 469 amps, and that's our first answer, right? That's going to be the answer for A1, right? So that's A1. A1, ta-da. I'll say that equals A1. Ta-da. There's my first answer, right? And then it says we got to find V1, and V1 is going to be IR. Right, so it's going to be that. No, I stored that in D, right? Okay, and then I'm going to use IR, so I'm going to do that current times this resistance, right? 8.429. Okay, so 3.469 times 8.429, right? Which for me is going to be D times C, right? Alpha D, enter. Alpha C, enter. Yes, okay. So alpha D times alpha C. I'm going to store that in, I guess we're on E now, right? E. That's 29.244 volts, and that equals V1. Ta-da. Right, so we got V1 now, right? And now we can, V1 is this voltage here, right? I'm done with this part of the circuit, and so I can just rewrite this circuit and just say, look, 29.244 volts is driving voltage through here, right, and through here. I'm sorry, it's driving current through here and driving current through there, right? So I can figure those out as well, right? And so now we can figure out the current through the 13 ohm, because I think they want to know that, right? Current through the 13 ohm. Oh, let's find, and we'll find the current through here, and then we'll also find V2, right? So the current through the 13 ohm is just that voltage, which is 29.244 divided by 13, right? So we stored that in E, but I've got it on the display. So I go divided by 13 is 2.249. 55 amps, right? And that is one of the answers, right? Right? Through the 13. Yeah. Okay. Now we can find the current through the 4 ohm. Right? And that's going to be that same voltage here. This same voltage, V1, right, is driving current that way, right? So it's 29.244 divided by, and then this is a little more tricky, right? It's actually 4 plus, what do we call this? A plus 5 plus 6, which is 23.922, right? 23.972. Right? Which is our B, right? So alpha E is this guy, and then alpha B is that other guy, right? So alpha E divided by alpha B, this is E divided by B, and I get 1.21992 amps, right? Ta-da. So that's the current through the 4 ohm. It's also the current through the 5 and the 6. And then we can find V2. V2 we're going to use, for V2 we're going to use IR, right? So, right? The resistance is 4 ohms, right? The current is, we just figured that out, the current is this current here, right? Okay, so that's going to be 1.21992 times 4, right? So times, oh wait, I got to store that somewhere. Let's store that in F. F. That's F. And then that times 4 is the answer to V1, 4.879. Right? So that's our answer to V2. Okay. And then we've got everything. We need V3. And V3 will let us solve for the current through the 9 ohm and the 19 ohm, right? So now we got to do V3. Okay, so V3 is going to be the voltage from here to here, and I'm going to use IR to do that one. Right, the current going this way is this guy right here, the one that goes through the 4 ohm, also goes through this mess, goes through the 5 and the 6, right? So it's going to be 1.21992 times that resistance, which is A, right? 8.972 repeating, right? But for me, I'm just going to type F, A, Fa, right? So alpha F, enter, is one, yeah, there we go, okay, and then alpha A is that. So alpha F times alpha A, and I'm going to store that in G. All right, so that is 10.945 volts, and then that's in G. Ta-da. Right, that's V3. Okay, so now we've got that voltage is here, it's driving current through there and through there, right? So the current through the 9 ohm will be the same as the current through the 8 ohm. It's a total of 17 ohms there, right? So the current in the 9 ohm is going to be just V divided by R. That's going to be this voltage, right? 10.945, or for me, G, right? Divided by the total resistance in that path, which is 17, right? So that divided by 17 is 0.644. Ta-da, and